Hello students, I hope that you are good, well and fine. So in today's session, what we will be seeing the leftover thing from the previous session. Okay, in the previous sessions, what we have covered, let us see. So you saw adjoint, some remarks and theorems, and saw the definition for singular matrices and non-singular matrices, and then some properties of adjoint. Now all of this theory will be what will be helping us to find the inverse of a matrix using adjoint. So let me just quickly recall you all of these this theory. Okay, so what do we mean by adjoint? Adjoint is just nothing but if you find cofactors, okay, and then you make a matrix like this and transpose it, matrix like this and transpose it, then the output will be your adjoint of A. Okay, we defined in this way. We saw an example like this. Quite simple. We all know about the cofactors of it. Cofactors you can directly or adjoint you can directly, if you remember what do we mean by adjoint, we saw adjoint just replace the main diagonal entries, so 4 2, and give extra minus sign to the remaining entries, so this will be your adjoint. Yes, if you remember. Okay, why? As you can see, first of all, the cofactor for this position A11 will be what? +1 multiply with M11. M11 will be this, so 4. Okay, as you can see. Okay, clear? The direct way to find adjoint of A of 2 cross 2 matrix. What matrix? If A is what? 2 cross 2, A11, A12, A21, A22. Just replace the main diagonal positions. Okay, so A22, A11. Now put minus sign to every remaining element like this. Then it will be your adjoint of A. That's what it is written over here in this remark. Okay. Okay. So theorem, we saw a theorem that A multiply with adjoint of A. We know A is a matrix. We know adjoint A is also a matrix. Then its output will be determinant of A multiply with identity matrix of the same order as order of A. Okay, you will get this. Okay, please memorize it, remember it. This will be very helpful in finding invertibility of a matrix. Okay, now another definition you saw about the singular matrices. Singular matrices when determinant is 0. Non-singular means non-zero. Okay, clear? So singular when determinant of A is 0. Non-singular means not 0. Okay, simple. A little remark about the non-singular. If you have A and B, two non-singular matrices, then what? The product AB determinant is also going to be non-singular. Okay, this means if A is not 0 and B is also not 0, then AB is non-zero and also be a determinant. We are talking about determinants. Okay, non-zero. Clear? Now we also we already saw this, that AB product determinant will be same as determinant of A, determinant of. Okay, we verified in case of 2 cross 2 matrices and 3 cross 3 matrices. Now I'm just recalling from the previous session. Okay, and we saw this as a fact that adjoint of A determinant is equals to determinant of A n minus 1. We saw this thing in case of 2 cross 2 and 3 cross 3. Okay, we verified this thing. Okay, we didn't prove any of the theorem, any of the main properties, as it can take what can you say, it can take time. Okay, and it is its proof is not so easy to understand or simple. Okay, Okay, let us move next. Now, invertibility. Now we will be talking about invertibility. Invertibility means existence of inverse of A. Okay, existence of inverse of A. Okay, so this theorem says, this is a theorem, you can say, a square matrix A, okay, is invertible if and only if A is non-singular matrix. Okay, this is saying that A is invertible if A is non-singular, and if A is non-singular, so A is non-singular if A is invertible, okay, invertible. Clear? Okay, how we are going to show that, prove that? Okay, let me give you real quick proof for that, as this proof is quite easy to understand. Now you all know A adjoint A multiply with adjoint A will give you what? Determinant A times identity. As A is non-singular means determinant of A cannot be 0. Okay, if this is this cannot be 0, then I can easily divide by determinant of A. Yes, as determinant of A give me the some real number. Okay, so this will be cancelled. Okay, now you left with this thing. Okay, now what I will do, I will pre-multiply with A inverse. Pre-multiply, I am doing pre-multiplication. Okay, in matrices, if you pre-multiply on the left hand side, you must pre-multiply on the right hand side. If you post-multiply on the left hand side, you must post-multiply on the right hand side. Okay, the same type of multiplication will be done. Now what? Now this will be identity matrix, as A inverse product with A will give you identity matrix, and identity matrix with any what can you say, any matrix will give you the same matrix. So this will be what? This thing. So, and this will be A inverse. So this means what? That A inverse exists. Yes, this means what? That A inverse exists, and A inverse is what? Adjoint of A by determinant of A. And we all know that inverse of A will be a unique matrix. Okay, there cannot be two different inverses of a same matrix. Okay, only one. So we can say that this will be, or my inverse of A will be of this form. Okay, so this gives me that it is indeed invertible. A is invertible. Simple, clear? Okay, so far so good. So this was a nice little proof for this. Okay, I hope that you understood. Now example, we will see example. A is given like this, then we have to verify this thing. Okay, and then using this we have to find A inverse. Okay, quite simple to do. Now what? A, we already know A. Let us find adjoint of A. Okay, so adjoint of A, I'll be writing adjoint of A. A is here, adjoint of A will be here. Okay, for adjoint of A, I need what? You all know, I need A11, A12, A13, the whole transpose, A21, A22, A23, A31, A32, A33. Or in other words, if I transpose, this will be changed to A12, A13. Yes, A21, A22, A23. Yes, A31, A32, A33. Okay, simple. Okay, now let me just find all the cofactors. So A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, first of all, the signs. So minus 1 power 2 means 1, so plus sign, minus sign, the sum will be odd, sum will be even, plus odd, even, odd, even, odd, even. Okay, please do verify also. Then what? Then it will be multiply with minors of respective position 1 3, 2 1, 2 2, 2 3, 3 1, 3 2, 3 3. Now M1, eliminate the first row, first column, first row, first column, find the determinant. So 16 minus 9, 16 minus 9 will give you 7. Yes, 16 minus 9 will give you 7. Okay, now what? Now eliminate first row, second column. Okay, 4 multiply with 1, 3 multiply with 1 will give you 4 minus 3, and minus already there, you will get minus of 1. Okay, now this will be eliminate first row, third column. So 3 minus 4, 3 minus 4 will give you minus 1. Okay, now eliminate second row, eliminate a second row, first column. So second row, first column. Okay, you will have 12 minus 9, so this will be minus of 12 minus 9. This will be what? As you can see, it will be minus 3. Yes, minus of 3. Okay, what about M22? Eliminate second row, second column. Okay, eliminate second row, second column. So far so good. So 4 minus 3, it will be what can you say? 4 minus 3 will be 1. Okay, so 4 minus 3 will be 1. Now eliminate second row and third column. Okay, second row, third column. Now 3 minus 3 will be 0, so minus of 0 will give you 0. Okay, now eliminate third row and first column. So 9 minus 12. Okay, so it will be 9 minus 12. This will give you minus of 3. It will be eliminate third row, second column. So 3 minus 3, it will be 0. Now eliminate third row, third column. So 4 minus 3 will give me 4 minus 3 will give me 1. Simple. Okay, now put the respective values. You will have A11 as 7, A12 and A13 both minus 1. Okay, now A21 minus 3, 1 0, minus 3, 0 and 1. Okay, easy. Now what you have to do, you have to just multiply it, and what you will get, let us see. So if you multiply, let me just multiply. Okay, so this going to multiply with this. So 7 plus 7 minus 3 minus 3. Okay, so 7 minus 3, this will be, okay, so this will be going to multiply with this. So 7 minus 3 minus 3 will give you what? 7 minus 6, and it will be just 1. So far so good. Now this will going to multiply with this. So minus 3 plus 3, 0 means 0. Okay, let me first of all also find the determinant of A. So determinant of A is just nothing. You all know that, as we already have cofactors, then I will be finding my determinant using cofactors like this: A11, A12, A12 plus A13, A13. So A11 entry is 1, multiply with 7, plus A12 is 3, multiply with minus 1, plus A13 is 3, multiply with minus 1. This will be 7. Okay, this will be what? As you can see, minus 3 minus 3 means minus 6. Your determinant will be 1. Okay. Now what? Easy. Okay. Simple to do. Okay. Now, as you can see, just multiply. So this now going to multiply with this. So minus 303 will give you 0. This multiplying with this again will give you 7 minus 4 minus 3. 7 minus 4 minus 3 will give you 7 minus 7 means 0. Now multiply with this. Minus 3 plus 4 plus 0 will give you what? 1. Multiply with this. Minus 3 plus 0 plus 3 will give you 0. Now this going to multiply with this. 7 minus 3 minus 4 will give you 0. Multiplying with this. Minus 3 plus 0 will give you 0. Now multiplying with this. Minus 3 0 plus 4 will give you just 1. Okay, 1. As you can see, this is what as determinant A. This matrix is what? Identity matrix, yes. And identity matrix, I can rewrite it as 1 multiply with identity matrix, yes, and 1 is just nothing but determinant of A. So it is written over like this: determinant of A multiply with identity matrix. So we have verified that it is true. Now we'll find A inverse. So A inverse is just nothing but, as we just already saw, A inverse is adjoint of A by determinant of A. Okay, adjoint of A by determinant of A. So adjoint of A is this matrix. Okay, so adjoint of A divided by determinant of A. Determinant of A is just 1. So this will be same as just adjoint of A. So adjoint of A, as you can see, 7 minus 3 minus 3. So 7 minus 3 minus 3. Okay, 1 0 0 1. 1 0 0 1. This will be your A inverse. Let us verify that it is A inverse or not. How you are going to verify? Simple. Just multiply with A. Here you must get identity matrix. So as you just saw, when we multiplied A and adjoint A, yes, this is what? Yes, what you are doing, this is your A, this is what? Your adjoint of A. You multiply A adjoint A, you got your identity matrix. As you can see, you got your identity matrix. So the inverse will be, so we also verified everything, and indeed we are getting the correct inverse. Okay, clear? Okay, I hope that you understood how we evaluated our cofactors, how we evaluated our minors, how we found out our adjoint of A. Okay, how we verified this thing, how we got our A inverse also. Clear? Now, as you can see, your answer. Okay, let there another example. So A is this, B is this. What we have to do is we have to show that A and B product whole inverse is same as this. Okay, let us show that. So we will approach using adjoint. So first of all, let me find the adjoint of A. So very simple to find. Just replace these positions. You will get this and put minus sign. Okay, so now adjoint of B. Adjoint of B is just nothing but replace the positions and multiply with minus sign extra. Okay, simple. Now what? Now A inverse will be what? A inverse will be adjoint. Adjoint we have already evaluated. Adjoint divided by determinant of A. Determinant of A, let me find determinant of A. So this multiply with this, what you will get? Minus 8 minus of 3, you will get determinant minus of 11. Okay, so far so good. What about my determinant B? 3 minus this. Okay, this will be just 1. So determinant of B will be just 1. So A inverse will be adjoint of A divided by determinant of A. Okay, adjoint of A is what? So I'll be writing like this: adjoint of A multiplied with Okay, clear? This is like this. Okay, now let me just make some space. So 1 by determinant A multiply with adjoint of A. Now adjoint of A just nothing, so it will first of all it will be this, and multiply with -4 -3 -1 2. Okay, now just multiply 1 by -11 inside. What you will get, you will have your inverse as 4 by 11, 3 by 11, 1 by 11, -2 by 11. This thing, A inverse will be this. Okay, A inverse will be this. Now what about B inverse? So B inverse will be 1 by determinant of B adjoint of B. Okay, and as you know, determinant of B is just 1, so B inverse is same as adjoint of B. Sorry, B adjoint of B. Okay, your B B inverse will be same. Now AB will be what? Let me just evaluate here. AB. So A is 2 3 1 -4. B is 1 -2 -1 3. You will have, so this will going to multiply with this. So 2 -3, this will be -1. Now multiply with this. -2 plus 9. Sorry, -4. Okay. Okay. So -4 plus 9, this will give you +5. Okay, +5. Okay, clear? Now what? Now this will going to multiply with this. So 1 plus 4 will give you 5, and this -2 -12. Yes, this row now going to multiply with this column. -2 -12 will give you what? Minus of 40. Okay, this is your AB. Now AB inverse will be, first of all let me find the determinant. So determinant will be 14 minus 25. This will be minus of 5 and 6 11. Okay, minus of 11. So far so good. Now adjoint of AB matrix will be what? As you can see, just replace this these positions, main diagonal positions. Okay, and put minus sign extra to remaining elements. Okay, you got adjoint of AB. Simple. And now what? Now just find the inverse. So AB whole inverse will be same as 1 by determinant of AB product with adjoint of AB. As you know, determinant of AB is -11. Okay, determinant of AB is just minus of 11, and adjoint of AB is -14 -5. Okay, so this will be -14 -5 -5 -1. Yes. Okay, as you can see. Now divide. So do the respective multiplication. You will get 14 by 11, 5 by 11, 5 by 11, 1 by 11. This will be your AB whole inverse. Now AB whole inverse, you got now product B inverse and A inverse. So B inverse, as you can see, where is our B inverse? B inverse is this. So B inverse, I will be doing B inverse A inverse. So B inverse is same as adjoint of B, which is 3 2 1 3 2 1 1. Now A inverse will be 4 by 11, 3 by 11, 4 by 11, 3 by 11, 1 by 11, and -2 by 11. 1 by 11 and -2 by 11. Okay. Now just multiply. So this is going to multiply with this. What you will have? 12 by 11 plus 2 by 11. Yes, this will be what? 14 by 11. Yes, 14 by 11. Okay, now multiply with this. What you will have? 9 by 11 minus 4 by 11. This will be 5 by 11 just. Yes, 5 by 11. Okay, and now multiply this row with this first column. 4 by 11 and 1 by 11 will give you 5 by 11, and 3 by 11 minus 2 by 11 will give you 1 by 11. Okay, so 5 by 11 here, 1 by 11 here. As you can also verify that this matrix is indeed same as this matrix. So we verified AB whole inverse is same as B inverse A inverse. Okay, as you can see our things. Okay, so what we have done, let me just quickly go through these steps. So we have to verify AB whole inverse is same as B inverse A inverse. Okay, so to find, first of all, to find inverse, what I need the adjoint. What I will be using, so adjoint some matrix. Okay, I need what? Determinant of the matrix given, multiply with, sorry, for to find inverse of a matrix. So matrix, given matrix, inverse will be same as 1 by determinant of the matrix and multiply with adjoint of the matrix. Okay, so we need what? Determinant, we need what? Adjoint. So first of all, we found these things. As you can see, for A matrix, adjoint of A will be this. In 2 cross 2, you all know that these main diagonal entries will be interchanged. You can see that -4 here, 2 here, and we put extra minus sign to the remaining entries. As you can see, minus here, minus here, then you can directly get your adjoint of a 2 cross 2 matrix. The same pattern will follow in B to find the adjoint. Okay, now what? Now determinant of A is just nothing but like this. So multiply these, then minus multiply these. Okay, so this is what I have wrote. -8 minus 3, you will get -11. The same pattern will follow. Multiply these and minus multiply these. As you can see, 3 minus 2. Okay, now you all know A inverse will be what? 1 by determinant of A multiply with adjoint of A. Determinant of A is 1 by -11 and multiply with this adjoint of A. I multiply it. This is just nothing but a scalar multiplication, okay, type of operation. So I did that. You will get your A inverse like this. Your B inverse will be same as your adjoint of B because of this determinant is equals to 1. Okay, now what you did next, AB, you found out your product of AB. Your AB will be this, then the determinant, then its adjoint, and then what? Then find A inverse, B inverse and A inverse product. You will get the same thing as AB whole inverse, as you can see. Okay, easy. Okay, I hope that you understood. It is quite lengthy process but quite handful. Okay, simple. Okay, now another example. So we have to show that a matrix, given matrix A 2 cross 2 satisfy this equation. Okay, so first of all we have to show that this matrix satisfy this equation. Okay, so first of all we find A square. A square is just nothing but A multiply with A. So 2 3 1 2 multiply with 2 3 1 2. This matrix will be what? Let me just quickly write. So 4 plus 3, it will give you 7. Now multiplying with this, 6 plus 6 will give you 12. Now this will be multiplying with this, 2 plus 2 will give you 4. Now 3 plus 4 will give you 7, like this. Okay, A square is this. Now 4A, what about 4A? Let me write 4A here. So 4A will be what? Now every entry of matrix A will going to multiply with 4. So this will be 8, 12, 4, 8. Simple. Now identity matrix, you all know about identity matrix of 2 cross 2, 1 0 0 1. Now a square, what I will be doing, so this is just nothing a square. Now a square minus 4a plus I'll be doing this operation. So this will be a square is just nothing 7, 12, 4, 7. Okay. Minus of 4a means 8, 12, 4, 8 plus I 0, 0, 1. Okay, simple. Okay, so first of all solve this. So 7 minus 8 will give you what? 7 minus 8 will be minus 1. 12 minus 12 will be 0. 4 minus 4 will be 0. 7 minus 8 will be minus 1. So this 1, 0, 0, 1. Now add these entries. So 1 minus 1 plus 1 will give you 0, 0, 0, 0. So you got your what? 0 matrix. So 0 matrix. So we have showed that this A matrix satisfies this equation. Okay, a square minus 4a plus I identity matrix will give you 0. 0 is here, 0 is 0 matrix. 0 matrix of order 2 cross 2. Okay, now using this information I have to find A inverse. Okay, let us see. So a square minus 4a plus I is equals to 0 matrix. Okay, this means I can write a square minus 4a is equals to minus, oh sorry, I can write like this. I identity matrix is same as 4a minus a square. Yes. Okay, now pre-multiply with a inverse, or you can say that post multiply with a inverse. Okay, let me just post multiply. So a inverse, this means 4a minus a square post multiply with a inverse. Okay, now this will be what? Just a inverse. This will be what? Using distributive thing, I can rewrite it as like this. Okay, and this will be what? A. This will be what? 4i. Yes. So this means a inverse will be your this thing 4i minus a. Let me just evaluate it quickly. So a inverse is just nothing 4i minus a, which means 4004 minus of a. We already know a is 2312. 2312. Now your a inverse will be 4 minus 2, 2, minus 3, minus 1 and 2. This will be your a inverse. Let me just verify it. So verifying. Okay, this will be your what? A inverse. Now verify. If it is a inverse, then a inverse a will give me identity matrix. So a inverse is 2 minus 3 minus 1 2, and a is just nothing but 2 3 1 2. Now just multiply. This going to multiply with this. So 2 minus 3 will give you what? So 2 minus 3 will give me minus 1. Okay, 2 minus 3 will give me what? Minus 1. Now what? Okay, so far so good. Okay, so 2 minus 3 will give me this. Now 6 minus 6 will give me 0. Minus 2 or plus 2 will give me 0. And this going to multiply with this. Minus 3 plus 4. Sorry. Okay. So 4 minus 3 will give me plus 1. Okay. And this will also give me plus 1. As you can see, you will be getting your identity matrix. Okay. So this matrix, this entry will be 2 multiply 2, which is 4, and minus 3 multiply with 1 will give you 1. Okay. Okay. So we verified that indeed we are getting the correct inverse. Okay. I hope that it is easy. So whenever you are given an equation, you first of all just verify that it is true or not. If question asks, if it is true, you already know it is true, then you can directly use that information to find out your inverse as we did. Okay. Clear? Okay. I hope that you understood. Let us move next. So I think here we have to stop, as this concept is just ended over here. Okay, so we will be back with the NCERT problem based on this adjoint and inverse of a matrix. Okay, using adjoint concept. So that's it for now. So thank you all.